did that on purpose. Well, good afternoon. I recognize that I'm Amy Elliott and I actually are presenting the TV class one, so we'll try to do this fairly briefly. As Mike said, I'm Tom Rogers, and I'm going to talk to you about a really, really cool technology this afternoon that Randall Ben, again, has invented. So I'm glad he's here to watch me butcher this technology. Correct me when I make a mistake. Don't be scared.
Your switch is not on.
How's that? Better? Yep. You mean our webinar audience missed that intro? That's horrible. Okay, so how would you like to be this guy? Or this guy? Or this guy? So I don't know about you, but this would be my reaction. I'm a little bit afraid of heights. And believe it or not, that's the standard industry practice when you're inspecting a flue stack. They take a big crane up and they lower somebody down inside it. So this technology was initially invented to take a look at the radiological issues around the stacks that are here on the lab campus. Okay. What's going on, how much radiological damage is there, how far does it penetrate, because it really mattered in terms of the waste management strategy. You have to know what you're getting into, because if it's just a little bit of surface contamination, that's one thing. If it's a little bit deeper, it's a much more serious issue. And so that was the genesis of this really cool idea and technology, but we believe it has applications in other places as well. There are a lot of aging industrial sites out there that need to be inspected and characterized. A lot of coal-fired plants that are being replaced. So I think there are applications that are considerably beyond its original purpose, and the current methods are clearly inexpensive or expensive and imprecise and unsafe. So the solution is called the Stack Robot. Really cool thing. It's a spider-like robot dropped by a cable. It can move from 5 feet wide to 22 feet wide as it goes down the stack. Capabilities of working with radiological detection, smear sampling, core drilling. It's battery operated, RF frequency, remote control. Just a really, really cool thing. Let me show you an animation. So there we have it. The Stack Robot has several what they call subsystems to it. Okay, it does several different things. It has an automated sampler that moves around, as you can see, and has sticky pads, and so it can take samples at various places up and down the stack. It's got a remote core drill that looks like a revolver, and that core drill can take core samplings from 2 inches deep at 6 inches deep, anywhere, again, up and down the stack, and then we'll bundle them, hold them until it comes back up for analysis. It's got a really, really interesting operator interface and control system. So it takes a look, real-time video inspection, does real-time radiological detection, could do real-time chemical detection with a very well-designed operator system. And it isn't just a concept. I mean, this is something we've built, okay? So you can see the size and magnitude of this thing. Now, I'm going to show you a quick video that was done during a demonstration of this technology. And I want Randall to, if you would, voice over this thing, will you? Tell them what they're seeing.
Okay, so this is the stabilizing tripod that centers the device in the stack and makes it so that you can rotate the bottom section where the instrumentation is located. So we have multiple cameras built into the system so that we can look down into the sides and up for that matter. So this is that sticky pad sampler extending out, making a surface sample on the sidewall.
Thanks, Randall. So there are several commercialization opportunities here. The Stack robot is available for licensing today, either exclusively or in particular fields of use. There's a potential opportunity to do a CRADA to continue to refine this technology. And I think there are some really interesting opportunities to apply what Randall's invented to other applications, right? Doesn't have to be flue stacks. Could be lots of other things. If you allow your imagination to wander, this event's called Spark. So, think about either the spider-like apparatus itself or any of the subsystems and ways that they could be used. The commercialization manager, we've said this a lot this afternoon, is Jennifer Caldwell, and she would be happy to talk with you, and Randall's here as well. So we really appreciate your time and attention. If you're interested in the topic, I ran across a really interesting report from the International Atomic Energy Agency that's long and detailed and has a lot of these pictures in it that really speaks a lot to the original intent of the technology. So that's it. Are there any questions that Randall can answer? William?
In the video, I didn't see an umbilical cord like power and video. I mean, is it autonomous and self-powered, or did I just miss the power connection in that video?
Okay, the system itself is all battery powered, so we don't have to deliver any power to it, but there's a radio link that sends all the data back and forth. So it's remotely controlled and wireless. That's correct. So really, you can deploy it with pretty much any crane system, and all that's required is that you have to have a receiver or transceiver antenna mounted up somewhere up on the crane. A lot of the stacks, of course, are steel reinforced, and you won't necessarily be able to transmit radio frequency in and out of the stack. So we go up vertically that way.
Are the testing devices and the tools you use for sampling, are they comparable to industry standards right now that are human operated?
Yes, that was the design goal. So the core sampling, for example, and the sticky pads, that's exactly what they do now, to take surface samples, core samples. And then also there was gamma sensors and that sort of thing where you had to move in close proximity to the surface. So we can do that with that device.
Great. Okay. Thanks very much.